I'm working on an AC series motor. Here is a series of video just I'm uploading regarding the motor winding, the AC series motor or universal motor winding. Actually on the internet, while I searched, very little information is available. One guy had worked somewhere from Egypt. He uploaded some video, but that is an experimental and design video which is not helping much. And another video which I found was from some foreigners. It was not English native language, but it was in some other language, but the work was very nice. Just I was impressed of the work, and I had been encouraged to do my own video series on AC series motor repair. So here is a chance I just got. This is what is a machine, you know. This is a motor or a complete impeller and motor assembly from a vacuum cleaner. Vacuum cleaners are using AC series motor or universal motors inside them. So this machine we are going to dismantle. We are going to rewind it, as the winding is bad for this. This was taking much more amperes. It was running not properly, and now is an opportunity. I just got it to dismantle it, to troubleshoot it, and to rewind it in front of you. So hope this video series will cover lot of information regarding rewinding. I'm not a rewinder actually. I just rewind some lot of transformers in past, but no motor. So this is my very first work, my very first job for an AC series motor. And AC series motor is a complex motor. It's not very simple. So we are going to make a chance, and just this video series will cover almost all details that a DIY can do himself, and one can rewind his motor himself. And it's very nice if you are rewinding a motor and it is running in the end and it is giving you proper results which you are going to obtain. So here, I hope this video will serve its purpose. Here is this vacuum pump motor. As you can see, these are the two terminals, power terminals, which are giving power to this motor, and then later on this motor is spinning using these two wires power. So this is a 220 volt actually. What I'm doing is I'm going to make maintenance on this and how to remove this from the vacuum pump. If you want to watch that video, watch my other video on vacuum pump vacuum cleaner repair. So this is not something I'm not going to show you over here. Instead, I'm just going to show dismantling of this unit, testing, and maybe later on we will do maintenance on this one. So for the first step, we have to remove this one. Here is the impeller inside, you can see, and this cover we have to remove it by prying. You are able to remove. This is rusty, as you can see. The rust is why, because it had been settled in some moist area for a certain time. So I'm going to do your work and just remove it using a prying by this way. Make your work and it will come off. It's coming off easily, not very difficult. And then later on, if you will see, here is a nut which is 12 millimeter in size. So we need a 12 millimeter ring spanner. If you will put it the 12 millimeter, it's not going in. So 13 millimeter we are trying. Sometimes it is 13, sometimes it is 12. So yeah, 13 is okay. So just we are grabbing, we are holding it over here, and then using our spanner we are going to remove this nut. So with this way, it's sometimes very much tight. Use your muscles power and remove it by some way. Here is the locking washer, you can see. We are going to remove this. We will not lose it. Instead, later on we will fix everything. So here's this impeller come off, as you can see, and the impeller had been cut off this flimsy plastic underneath, and this is only a plastic, just a spacer or whatsoever you can say, but it will do even it is cut or burnt, whatever. So it came off. Sometimes it is screwed, as you can see. It was screwed, but unfortunately it was not now. Something happened to it. It came off very easily. Put it inside, and then later on, as you can see, this assembly, the cover, the end cover here, and a few washers. Of course, we have to remove them like this. These we will put later on while we will assemble this thing. And then these windings, you can see, they are exposed. Later on, there are sometimes 4 screws, but now there are 3, as one had been loosened somewhere before. So I'm going to remove these three using my Phillips head screwdriver. Straightforward. Just remove. Like this, and keep them aside, of course, to reuse them later on. And now I'm just bringing it off. Here you can see this is a bearing, and here is the end cover. This bearing was embedded in end cover. Sometimes you need a little bit hammering on, but this time it was not. Okay, so what we will do later on is we have to remove things from, and of course what we will do is we will have to remove this thing from the inside out, and we'll see what is bad with this unit. So for this purpose we have to make a little bit hammering over here, and then by that way it will come off. So by some way, using a little bit stronger screwdriver and sort of hammer, I'm just using this spanner. I have a hammer but not at the moment over here, so I have to hammer it. It will come off. It came off, as you can see. These are the parts actually. Just I'm going to show you. Here was one spacer. This is a ferrite spacer. They have put it in. Okay, we will put it later on over here. So these are the two parts. Just I'm going to show you which parts they are. Here is the whole part. This is known as armature. Armature have winding, and of course it have this one commutator part. Commutator is segmented. Copper segments are there. These are for beginner actually, not for the specialist, of course. And here are two bearings on this. So this envelope, this armature is rotating on these bearings, and here is the stator part or the field winding. You can see this is the field winding, and the power is coming to one of the winding, and then through the carbon brush it is going to the armature, and from the armature it is coming on the other brush, and of course it is coming to the other winding and then going back in another wire. So this is what is the circuit. Something straightforward, but it looks straightforward, but the windings are a little bit confusing, or whatever you can say, little bit tricky. So what we will do is we will have to test this thing. For the testing, actually we need a ruler for the professionals, but for the ordinary person, ruler is not there. So what we will do is we will use our multimeter to test this thing. So here I'm putting my multimeter and putting it, of course, on the ohm range, because we are going to make the ohmic test for this thing. And testing is straightforward. You have to check it in the 180 degrees, somewhere 180 degrees, the segments we have to check, and something 2.1 ohm resistance I'm getting. So later on we have to move it a little bit and test it. 2.1. Okay, so next are the next segments we have to check. 2.2. Next we have to check for the next segments. 2.1. Next we have to move it more. Video. 2.1 and move it more. 2.1, 2.0. So this way we have to check all. And then another test is we have to check the adjacents. The adjacent should have a certain value of resistance, and all the adjacent segments should have the same resistance. As now I'm going to test it. 0.7, 0.6, 0.6, 0.8. So there is a definite resistance which I'm getting. So this should be the same. If it is not the same, so this unit is bad. Then we have to rewind it, and of course we will rewind it because this is bad. I know it. The resistance value, I cannot agree on that, but we will try to rewind this unit. I will show you how to do it in the later part, or something like that. This is a tricky work actually, the rewinding. How we will do is I will show you the whole procedure. So keep on watching, stay tuned, subscribe and like the video for the further parts.